Okay, so let's get started. We're going to be taking a look at working with our comparison feature and the import and export features found in our PC Link software. Now, these are going to be a huge time saver in the case of the import export feature, as we're going to find. They allow us to build a very rapid base map for things like our fuel table, spark timing table, boost control tables. We're going to get into all that here, just taking a look at some demonstrations of using the import export feature. The comparison feature is another very valuable tool that's going to allow you to compare two different files and highlight the differences between them. So if you're trying to figure out, maybe as you're starting a calibration process, maybe you're looking at what you've done in the beginning compared to what you've ultimately ended up with in the end to get the car tuned, it'll allow you to see those changes very clearly. Let's go and first take a look at the comparison feature. This is something I use a decent amount when I'm trying to figure out maybe a difference between two files. So pretty easy to demonstrate this. What I'm going to do is use an example of a vehicle that I was doing some remote tuning with, and we're going to take a look at the first file that we started off with, and then take a look at the end result, and we can see all of those differences, see all the things that were changed. Let's jump in here and take a look. I'm going to go up here to File, and I'm actually going to open the file that I first started off with, and then we'll use the compare feature and compare my original file to the end file. So again, we can highlight those differences. So I'll go to File, Open. And if we go down here, it's this 2JZ VVTI example. Let's pop in there and grab this E2 number 1. So this is where we started off with. Now this is showing me that this particular file was built in a older version of the G4X software. This is actually a G4X file, although it will work with this new G5 software. They are cross-compatible. So let's go here and just click OK. Just click OK here. And now the next thing we're going to do is use that compare feature. So we're going to go up here to File, and then we're going to go to Compare. And then we're going to go back into that folder to compare the two files. Let's go here. And we're going to grab that very last E2 number 3E. This is that last revision over the course of doing all of that file, or that tuning, I should say. So first things first, we're going to notice that we can see and spot the differences. So as we look in here, we do have the option to close out this file. Wanted to quickly mention that. But if we look in here, we're going to find the breakpoints, for example. Anything here that's in the black color on our breakpoints, those are the original file breakpoints. Anything in the red, that's what is from the new file we're comparing against. We can easily spot those differences. Now the breakpoints haven't changed between the two files. As taking a look at this, everything looks the same. I usually don't change the breakpoints once I set them. However, the volumetric efficiency table has been changed. So looking at this, we're going to notice the original file started off with values of something like 42 in the cell point. We ended up with a value of 34, 35, and on as we look through the table here. Let's just pop into some different areas. So just take a look here, for example, fuel trims, cranking enrichment. Again, looking at the breakpoints, those haven't changed. The black is the current file. The red is the file we're comparing against. What has changed are the values. We can see it looks like everything in the red here is higher on the colder coolant temperatures. Looks like I bumped up the cranking enrichment to be able to get the car to fire off a little bit easier in this case. Now, if there are no differences within certain tables, you're going to find that they don't display anything. So for example, crank hold time, post-start enrichment, post-start hold time, post-start decay time, pre-crank prime tables. Notice that there's no data. You don't see anything here, two sets of data in the table. It's just all just the breakpoints it's essentially highlighting. This means that there are no differences. If we take a look here at something like the cranking enrichment, it does compare both files. The left side column here, anything in the left would be the original file. The right side would be then the new file we're comparing against. So it looks like the pre-crank prime, I did change that from 40 to 60 right there. We can see that. That's going to be one other example. Let's take a look here at spark timing. Spark timing has been changed. Again, we can see the table here showing any of the breakpoints highlighted. So nothing has changed in the breakpoints between the red and the black. But the table values looks like there might be some slight differences here. So taking a look at this, looks like there were some changes that were made to the IAT compensation table. So you're going to find there has been some changes along the way in there. So again, as we poke through the file, we can compare the two and clearly highlight the differences and what has changed. So this hopefully should make sense using the compare feature. Let's go ahead and close the compare feature out for right now, since we understand the idea of what we're looking at here. Let's go to compare close, and now it's back to just that original file. So we poke through here. It's going to show just this singular file as we're looking at the data. All right, so the next thing, which in my opinion is a huge, huge time saver with this PC Link software, and why I'm having essentially a dedicated tutorial, almost, obviously we're using the compare feature here, but the import export is really the focus of this tutorial. This feature is a huge time saver if you know how to use it correctly and you're implementing it properly. Let's look at how we can work with this. For example, right now, I'm in this file. We can see here, this is that eTune tune file. Let's go into a generic file and take a look at a few things. I'm going to go to File. I'm going to go to Open. And in this case, I'm going to go to the base map directory and actually open up one of the base files from Link. So we can go in and learn how we can essentially overwrite a lot of that data that's in the file and use something that's going to be kind of a more universal approach to getting pretty much any engine fired up on the Link. All right, let's go in here to our C drive, and that's going to allow us to pop into our G4X, go into our G4X folder, the base maps. This is going to be the large directory of all the base maps in here. Let's just go open up one of these files. For example, here we're going to grab the Honda Integra Type R. Let's just go ahead and open that up. I am using a Honda K-Series engine, but for my particular G5 that I have it set up and wired onto here. But let's take a look here. So this is going to be their base file. It is compatible with a G5, so G4X files can be loaded into a G5, but input and outputs are probably going to be different. Those all need to be configured. We're going to talk about how to do that. Future training tutorials focus on setting up inputs and outputs. Let's not get too weighed down in that right now. What we want to do here is create a file or a base file pretty quickly. If we jump in here, we look at the basics. This is my tuning template for the training course, and we're going to go over this pretty heavily as we kind of go through some things a little bit in future training modules. So just popping through some of what I have here that I use on a pretty frequent basis so I can see everything. Now, when we're looking at this, what I want to do here is start to bring in information and data. And without having to go in and populate and hand edit tables, so meaning I have to go into something like my injector data, I don't want to have to go in here and populate this information. We'd have to hand enter this in from an injector data sheet. Let's assume that I'm running injector dynamics injectors, injector dynamics 1050X injectors. I want to be able to pop that information in here fairly quickly. I know that the rated flow pressure of a IED 1050X injector at 300 kPa is 1065. So I'm going to enter that in. That's easy to enter in. These table data points right here, so our injector dead time data and our short pulse width data, that has to come from a data sheet from ID or whoever the injector manufacturer is going to be. And again, we're going to get into what all this means. I don't want to get too heavily into this right now, but what we want to do here is learn how we can use the import feature and bulk import the data. So this base file from Link is not going to account for my injectors. I've entered in the injector flow right here. I need to enter in the dead time and short pulse width. If I right click on the table here and I go into this option, import export, we can go here to the import from file. There's an import from clipboard, export to clipboard. We'll talk about that here in just a little bit. We're going to be working with the import from file option. In our G5 training course folder, you're going to find a calibration file subfolder. Let's click on this real quick. What we're going to do, go to the desktop, G5 course packet, and we're going to see we have this calibration file subfolder. Let's click on this. In here, I'm going to find a subfolder that's going to be injector data. Double click. I have all of the injector data for injector dynamics available within here. What I want to do right now is grab my ID 1050X injector data. Now, this is going to be three-dimensional latency data. So fuel pressure versus battery voltage. The way that we currently have this table structured, this is a two-dimensional data. It's just taking into account battery voltage. We want to change that up a little bit. Let's change our dead time table. Again, we're going to get into all this, what this all means. I'm just demonstrating using the import feature. So let's grab 3D table and set this up. Click yes. So now we have this three-dimensional table that we have to populate. This would be an absolute nightmare if we had to enter the data in by hand. Injector Dynamics does provide that for us, but we can bulk import that information using a calibration file that we've potentially created. I'm supplying a lot of these for you, so you have that as a good reference point. But let's learn how we can use the import. So again, we'll right click, import. Let's go to import from file. Let's go back to our injector data folder. Again, that's going to be found in our training course. And actually, we have to go to our desktop, G5, calibration, injector data. And we're looking for the ID 1050X. In this case, that's the injectors that have 3D latency. Let's click on that. Automatically, all of the data that needs to be populated into the table is brought in here. The table is structured and set up for us. We don't have to do the heavy lifting by entering in all the data from a data sheet and putting it into the format here. I want to do the same thing with my short pulse width. Let's bring that information in. So right click, import, and notice that it keeps taking us to this specific location here. C drive, link G5, PC link G5, calibrations. I've actually imported all of the calibration files that I've provided from the training course in here already, but in this case, you'll find that you're probably gonna have to go source it from your desktop at the moment. So let's go back to injector data. Let's click on that, and we're looking for ID 1050X short pulse with data. Click enter, automatically populates that. So you can see how powerful this is for working in the table. Let's demonstrate something else here. Let's go to fuel. This fuel table here is only going to account for a naturally aspirated engine. That's the base file from Link. It's supposed to start up a stock equivalent K20A2 engine. In this table, let's assume that I want to build this for a turbo application. The MGP here is not accounting for any positive manifold pressure. 0 MGP kPa would be the equivalent of atmospheric at sea level. So obviously if we're going higher than that in manifold pressure, turbocharged, this table won't work. How do we solve this? We can build another rapid base map file here. If we go right click, import from file. In this case, we're gonna go down here in our menu, go to VE fuel table, and then we have some options here to select. I'm gonna select fuel table 1, 200 kPa. We have different options in here. We can select different tables I've built out that are pre-configured, automatically populated the table. So now I have something that's gonna be pretty close. That's gonna give me a good starting point. Let's look here for our target lambda table. So let's go right click here. Let's go to import export, and I'm gonna go here to import from file. In this case, I'll go to closed loop fuel control, and then I have different target lambda tables. I'm gonna grab air fuel lambda target, select that, we see automatically populates an appropriate table for a turbocharged engine that's going to be running on petrol fuel, it looks like. So I have now entered in my injector data. I've entered in a good VE table to start off tuning with, as well as my target lambda table. Again, all of these tables and what they mean and how they work, we're gonna get into that in separate training modules. What we're trying to understand conceptually here is using that import from file feature. Again, I'm providing a really solid list of tables and settings that you can bulk import like this and build out a file very quickly. So we understand the import option. Now let's assume I tune out this field table. This is my starting point. I end up with a completely different table when I'm done. That's fine. Let's assume that we want to take that table data and export it out now and build our own calibration file. As you do more tuning, you're going to find that you are able to generate good starting points for other base maps. So if I want to export the data out, I'll go here and right click. I'll go to import export, and I'll go to export to file. Now what this is going to allow me to do is save this as a unique calibration file that we can select out of these folders, and then I can retrieve that using the import feature at a later point in time. So the export to file allows you to build your own table or data to export out of a good file, and then you can use that at a later point in time to import it back in as we just demonstrated. So hopefully that makes sense. Now there is the option here that I want to go and demonstrate, and that's going to be the import to clipboard and then export to clipboard. Let's understand how this works. Let me pop over here in my layout, and let's just go here to flex fuel. Now in here, I'm gonna turn on the flex fuel option. Actually, I have to pop back over here real quick. Again, don't panic. I'm just demonstrating using the clipboard feature. So we just want to take a look at this. We will break down how to set up flex fuel and to work with this in another training module. I'm just trying to illustrate this import export clipboard feature. I'm gonna go in here and change this to model multi-fuel, and that allows me to then go into my flex fuel here, and I just want to demonstrate doing this data transfer, essentially building out tables. So in this case, we're set up right now to do model multi-fuel, which is flex fuel mode. And I want to go in here and set up a few things. Now, while I'm in the flex fuel option, I have this multi-fuel blend ratio table. I want to go ahead and configure this. I have a predefined flex fuel template for the multi-fuel blend ratio table that needs to be filled out. If I go in here and I right click, import, again, I'm going to import this. I'm just going to do this real quick. We should have flex fuel here. We have multi-fuel blend ratio table. We can see that that's brought in there. We have a air fuel lambda target table. Now, when we're dealing with doing flex fuel tuning, there may be the potential to change your desired target lambda or air fuel when you're working with ethanol fuel compared to petrol. Your air fuel table 1 would be for petrol. Air fuel table 2 here would be for ethanol. Let me go in and demonstrate this real quick. If we can take a look here, you want the tables to be the same in terms of your breakpoint layouts, and the table data can be different, but the breakpoints are essentially have to be the same. This is important because it's going to interpolate between the two tables for flex fuel. We'll get into what all this means later. But what we essentially want to do here is take the table data from our target lambda table here and bring it into our new target lambda table 2, because let's assume that we don't want to change our target lambda. We just want that as a starting point. We can always edit and adjust this building our base file, but we want to be able to do this data transfer fairly quickly. In this case, what I'm going to do is use the export to clipboard option. It's going to export this table data, not save it to a file that we can actually go back and retrieve, but it's just going to save it to a clipboard. Then we can import it into this table to make that table match the same, just to move along the calibration process. So let's just demonstrate that real quick. Right click here on the table, go to import export, export to clipboard. Now notice, it's not asking me to save the file anywhere. It's saving it to the virtual clipboard. I'll go in here, right click in the table, import export. Now we're going to use the option import from clipboard, and now the table is identical. So this allows me to now make the tables mirrored, and then I can come into this table and change this whatever I'd like. Let's say at high RPM here, I want to target 90 lambda, and then I can do some interpolation here if I'm kind of moving through the file. Maybe I want to go ahead and target a little bit richer lambda mixture when I'm in boost. So we can change up that file, but the table data. But what we're finding here is that it allows us to do that table transfer, that table data transfer fairly quick. And if we like this table, let's say we build this out real quick by hand, we right click, import export, export to file, save this as a specific file, you can retrieve that back in and use that import from file feature to maybe build this out the next time, instead of going in and using the export to clipboard and then import to clipboard option. So that's how that would work, and hopefully this makes sense. Again, we're talking about some specific things here in the software: setting up injector data, setting up a V table, setting up target lambda table, setting up flex fuel. These are going to be something that we cover in specific tutorials, so we can dig into these topics very heavily and understand what it all means. But understanding, using the import export feature, understanding that I've provided a lot of the calibration data for you, is going to save you a tremendous amount of time. I use these features almost every single time I'm doing any calibrating and tuning with the Link system. It saved me hours and hours and hours of time. So very important understanding it and you being able to use it in your calibrating and tuning with your Link. That's going to wrap it up here for this training module. Any comment or questions on anything we cover in this training tutorial, post your comment or questions into the video comment section or into the private forum. I'll see you guys now in future training tutorials.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.